And wait for the little red. There we go. Okay, so that's going and we are recording. Let me remind everybody that your last day of class is Monday. We will go over the last test and homework questions and maybe, I don't know. I don't know if I'm going to go over 9.2 or not. I'll decide that over the weekend. And the homework will start on, the homework will start on, will end on the 23rd or 24th. I can't remember which one I did. And the final exam and the last test start also on the last day of class. So if they hadn't already, I may have already posted it. I can't remember. But they will end on December 7th because you got Thanksgiving break in there also with the exam time. So it's kind of like you got 2 weeks because we get out right before Thanksgiving and then y'all have Thanksgiving break, and then December 1st through December 7th is final exam week. So you have a couple of weeks to get your last test done as well as your final exam. Also, I need for you to make sure, y'all are not following directions already. I've already had 3 people send me their, I want you to turn in your projects on the last day of class. That don't mean now. It doesn't mean after the last day of class. It doesn't mean before the last day of class. It means the last day of class. So y'all will turn in your projects on the 23rd, which is Monday. Okay, I'm really not going to be picky as long as you make everything neat and organized and readable. I don't really care whether you have pictures or diagrams or, you need to have something. Honestly, you got to have something. You got to have at least a couple of pictures of what you used, and maybe a couple of normal curves or just draw the dot plots or, of what you did. Just some information. I'm not going to sit here and tell you got to have A, B, C, and D. I sent you the handouts, and I'll go ahead and show y'all, which I shouldn't have to because y'all know this. Anything pertaining to this class, you go to files, and there's the data project reflection, the data project PowerPoint, and down here there should be a data project assignment. Okay, so make sure you read and go over those 3 things. And again, it's not supposed to be rocket science. Just do the best you can. Like I said, this is not my project. This is not the math department's project. It's something that's outside the math department. So we really, all we're doing is just following along with orders. So I'm probably going to be very lenient on the grading of it because it's 10% of your grade, and I really don't want to have to fool with it. So I'll grade accordingly. If you've got a real nice presentation, you're going to get 100. If you got a half-ass presentation, you're going to get like a 60 or 70. But it's only 10% of your grade. So just turn in something, but make sure, what do you put in the subject line? Anybody want to volunteer what you put in the subject line?
Math 12024 project.
Thank you. Yes, Math 12024 project. So some of y'all deadheads, I don't think I have any deadheads in here. Please don't put 120 project because I'm just going to return it and say, please follow directions. Okay? I'm not going to take the time because you're lazy or you don't follow directions. I'm not talking to y'all. I'm talking to students in general. I'm telling every one of my classes, please follow directions. put the section number on the subject line, please. Okay, because I got 2 Math 120s. That means I've got close to 40-something students. I don't want to have to spend time with 10% of those students, 4 or 5 of those students, putting project in there. I'm going to send it right back. I'm going to say, please follow directions. Okay. So anyway, that's that. And let's go over some problems. This is 9.117/5. Okay, this is construct a 99% confidence level. So go ahead and write that down. I'm going to pull up my handy dandy. I got to get there it is. Pull up my webcam. And pulling up my handy dandy index card for the 2 or 3 of y'all that did what I told y'all to do. 99% confidence level. So according to our index card, a 99% confidence level gives us a z-score of alpha over 2 equal to 2.576. Okay. That's what our index card gives us. And we've got X is equal to 40. And this is a good test question. And N is equal to 200. And that black one is dead. So, what's the first thing? Got to find P hat. P hat is equal to 40 over 200, which is, I'm going to divide by 2 over 10, which is equal to 0.2. Therefore, what is Q hat? If P hat is 0.2,
0.8.
Thank you. All right, and that's pretty much all you need to do your 99% confidence level. They're wanting a confidence interval. Remember this. Some number less than or equal to P hat, which is 0.2, less than or equal to some number. That's what they're wanting. They're wanting a confidence interval. So we've got to have a margin of error. So margin of error is equal to our z-score times the square root of P hat Q hat over N. Now I want you to plug and chug because I just got an email. I want to check to see what it says.
You have a work email.
I want to see if it says anything about the. I hope you're doing well. I've gotten reports from other instructors about the same issues. I've alerted my manager, and IT is aware. Okay, good. They're on it. You're welcome. I done lost my pen. What did I do? There we go. All right, so the margin of error is going to be equal to 2.576 times the square root of 0.2 times 0.8 divided by 200. So I'm going to take my handy dandy calculator out, because if I ask y'all, y'all won't tell me. So I have to do it myself. And I know Miss Stewart and some of the other people get tired of answering every single time, and other people that are weaned on the pickle don't. So I'm going to do it myself. 0.2 times 0.8 divided by 200 and multiply and raise that to the 0.5 power, take the square root of it, and then multiply that by 2.576. So my margin of error is 7%. Now, I don't know what they want, so I'm gonna round that to 7 decimal points, because I don't know what they want. So I mean, not 7, 4. 4 is always a safe number. 0.729. 0.29%. So you've got a margin of error of 7.3% or 7.29%. Is this research good? No, it's not. Margin of error that high should not even be printed. Okay, it shouldn't even be put in a magazine or a news article or a TV news article or whatever. It shouldn't. 7% is too high. But in this case, we're going to take this number right here and we're going to add it and subtract it to 0.2, because 0.2 is in the middle. So what is 20 cent plus 0.729? Well, that'd be 2.729. So down here, I'm going to add it, would be 0.2729. And if I subtract it, I'll do the calculator. 0.2 minus second answer, 0.1271. 0.1271. So your confidence interval is between 12% and 28% or 27%. So let's look and see what the answer is. The lower bound is what did it say round to? 3 decimal places. 0.127. And the upper bound is 0.273. All right, I'm going to hit similar question, since we just finished 9.1, and I want you to do it. All right, you try this one. Still, it's a 99% confidence level, so you're still going to use that 2.576. Give y'all a minute to work on it. Okay, so in this case, I'm going to rewrite and Z, 99% confidence level, is equal to 2.576. X is equal to 175 and N is equal to 250. So P hat is equal to 175 over 250. And I'm not going to reduce that. I'm just going to do it. So 175 divided by 250.7. Therefore, Q hat is what? What is Q hat? 0.3. Now, the reason I keep asking y'all that is because the number one question I get at the end of the semester is how did you get to 0.3? Even though I've been talking about the complement throughout the whole semester. Okay? Complement of 0.7 is 0.3. Sorry. Okay, we've got that. We know that we're looking for a couple. So the lower end is there. The upper end is right there. The margin of error is equal to Z times the square root of N, P hat, Q hat over N. And I keep writing the formula over for the same reason. Z is 2.576. The square root of 0.7 times 0.3 over 250.
You have a work email.
My boss is going to kill me. I bet she hasn't even woke up yet. She getting all these emails. No, I thought that was her. But they are working on it. There's been 3 emails sent from Pearson IT working on the situation. So, all right. So pull up our handy dandy calculator. And 0.7 times 0.3 divided by 250. And take the square root of that, raise it to the 0.5 power, and multiply that by 2.576. .04%. 0.0747. 7.5% margin of error, which is not a good margin of error. So I'm going to add that to 0.7. Add to 0.7. And that's going to give me 0.7747. And subtract it. Oh, I did the wrong one. 0.7747. And then 0.7 minus 0.0747. 0.0747. 0.6253. So our confidence interval, a 99% confidence level, based on a confidence interval based on a 99% confidence level with X is equal to 175 and N is equal to 250 is 62.5% to 7.75%. So let's go back to our answer. And 3 decimal places would be 0.625. And 0.775. And those are 2 good test questions that I would ask you on the test from 9.1. Now I have it covered. Let me see. Well, let's go on and do 8. All right, these are 8.2. Let's see if we got any repeats. That's 8.2, 18, 16, 13, and 11. So we'll start from 11. So this is 8.2, 11, number 6. Okay, suppose a simple random sample, n is equal to 150, is obtained from a population. So little n is equal to 150, and big N is equal to 15,000. And we have P is equal to 0.4. Okay, first of all, let's check our test. Okay, our tests are NPQ has to be, is it greater than 10, greater than or equal to 10? And little n has to be less than or equal to 0.05 of big N. Okay, those are 2 tests. Let me take my handy dandy pink, and that's our 2 tests that I told you about several times in chapter 8 to check to see if this is a binomial normal distribution. So N is 150 times 0.4 times 0.6. So handy dandy calculator, 150 times 0.4 times 0.6. 36. Is 36 greater than 10? Yes. So 36 is greater than or equal to 10. So that checks. And then 150 is less than or equal to 0.05 of 15,000. So handy dandy calculator, 15,000 times 0.05. 750, so 150 is less than or equal to 7, and that checks. So the test check. All right, so let's go back to the question. And I guess it will be this one. It's already checked. Now the mean is equal to P. So whatever they asked for, the mean, this is also the mean. So 0.4 is your mean. Now they're going to ask for a standard deviation. Let's see if they ask you anything before that. Determine the standard deviation of the sample size distribution of P. Well, remember, and I'm just going to bring this up again, it's P hat Q hat over what? Over N. And I'm just going to show you right quick. There it is right there. P hat Q hat over N. So deviation is equal, I'm going to write it down for you, square root of P hat Q hat over N. And that's equal to the square root of 0.4 times 0.6 over 15,000. So handy dandy calculator. I was going to try to make it a little bit smaller. There we go. So move this over here a little bit. 0.4 times 0.6 divided by 50,000 and raise that to the 0.5 power. Crap. 0.5 power. That's 0.004 times, well, that's it. I forgot, I was going to multiply it by z. All right, so 0.004 is your standard deviation. So 0.004 should be, or did I write it down wrong? Okay, I don't understand why that's 0.04. Did I do something wrong? Let me do it again. 0.4 times 0.6 divided by 15,000. Raise that to the 0.5 power. I got 0.004. So I don't know why I can't click on it. So I guess I don't know if that's the right answer or not. What is the probability of obtaining X? Okay, so we got a new probability right here. I mean, a new X. So, and they want to know if it's going to be above 0.42. Okay, so remember, mean is the mean is 0.4. And now we got 63, so we got a new N. Okay, so we go down here and we draw a line under here and we say new N is equal to 63. I'm bothered about that 0.04. Did anybody get 0.04? And
I
of
came
course,
up with the
nobody
same
said-
thing as you.
Okay, thank you, Miss Stewart. I'm looking, I'm gonna see. See, they don't have a 0.0028. I just wonder if they're rounding. 0.0028. Let me see what they're doing there. Rounding. So 0.7 times 0.3 divided by 75. Well, that's right. And then raise that to 0.5 power. Yeah, that's not a problem. But see, they got an N is 75. We got a dadgum N of what? 150. Wait a minute. I'm sorry. I'm dividing by 15,000. I need to divide by the little n. I'm sorry. 150. My bad. I messed up. I'm sorry. I divided by 15,000. Supposed to be 150. I knew there was something wrong. Easy mistake. I grabbed the wrong n. I grabbed big N, not little n. So that should be 150. Not this one. This one. Oops. So that would be 0.04. The reason I had to fix this is because you have to fix this, because if you're going to use this material down here, it's going to come out to be wrong. There we go. Okay, my bad. And now they should draw a picture. I'm making sure I'm reading this right. You got to take the new end. There we go. Yeah, they're going to draw a picture. And the right of 0.42. So 0.42 would be, you know, with a mu of 0.7 and a standard deviation of 0.04. So I'm thinking out loud. And then, yeah, just punch it in your calculator. So I just wanted to make sure that's what they were doing. So I'm going to draw a picture. And that's 0.7. I'm at 0.4. And this is going to be 0.44, 0.48, and 0.52. And this is going to be, let's see, 0.36, 0.32, 0.28. Okay, they want to know if it's greater than 0.42. So 0.42 is going to be right here. So they want to know that area right there. But they also give us a new X. And that's 63. So we're going to have to do a new standard deviation. So let me go back to the calculator, or let's just do it right here. So with a new N of 63, that's going to be the old standard deviation of 0.04 divided by the square root of 63. And that's going to give us our new standard deviation. So that's going to be, let me do that. That's going to be 0.04 divided by parentheses 63 raised to the 0.5 power. And that's going to be 0.0050. Let's go ahead and check 0.42 and let's see if that's what they're wanting, because that kind of threw me off when they threw that 63 in there, because that's too low of a standard deviation. That's 0.01. So that would be 0.41 right here, 0.41, 0.42. So that would be this area right here. I'm thinking out loud. So you might want to put in a new standard 0.01. I'm trying to figure out what they're really. I'm going to go back to the question, because if I can find my mouse and go back to the question, which I cannot find now. There it is. What is the probability of obtaining an X is equal to 63 or more individuals with a characteristic? That is 0.42. So I'm going to go with the original, and I'm going to go with the 0.42 to infinity. So let's go with normal. I'm going to go make it bigger. Let's go with clear, second, bars, normal CDF. And the lower is going to be 0.42. The upper is going to be 9999. The mean is going to be 0.4. And this is where I'm a little bit unclear what the question is asking, because you could actually have two standard deviations. The standard deviation I'm going to use to see if this is 0.04, but I believe it's supposed to be 0.01. So I'm going to put 0.04 right here, but we may get the wrong answer and have to go back and put 0.01. Yeah, that's too big. 31%, 0.3085. I think that's wrong. 3085. 0.3085. No, it's right. I don't like the way they got this question asked, because it's a little bit tricky. That's probably why Miss Hicks, that's probably why you sent it. Or who sent this one, Miss Yates or Miss Hicks? That's misleading when they, okay, did you get confused because of the 63?
Yes, sir. And the next few problems are like that.
Well, now you're going to do from negative, so just type in, I think they're trying to throw you off. They threw me off. Second entry, and now I'm going to change it from 0.9999 negative 0.9999 comma 0.34. Oh, just forget it. Second bars. Let me get out of this. Hold on. Second bars, normal CDF, negative 9999 to 0.34. 0.0668. 0.0668. Yeah, they're trying to throw you off. I don't know why they're throwing that obtaining x is equal to 63 or 51, but they're trying to throw you off. So the only thing you need to concentrate on is just ignore this and just do 42 and 34, because it threw me off. Let's do another. Well, you probably got another one like this one. Let's go ahead and do another one. This one right here says 8.213.7. I don't like that question. I hope this one's a better question. Suppose that a random sample of n is equal to 1,000. So n is equal to 1,000 is obtained from a population whose big N is equal to 1 million, and whose population is P is equal to 0.48. Therefore, the mean is equal to 0.48, and Q is equal to 0.52. And they want to know what the new standard deviation is. And that would be standard deviation is equal to the square root of PQ over little n. And that's the square root of, sorry, make this smaller. So 0.48, 0.52 over 1,000. And that's going to be 0.48 times 0.52 divided by 1,000 and raised to the 0.5 power. 0.0158 or 0.02. Okay, that's what I got. And I think that's it right there. Yep. What is the probability of obtaining 510 or more? So plug it in. We're going to draw a picture. Okay, now 510, you can't do 510. So you got to change 510. So that's going to be 510. See, these questions, they're trying to trick you. X is equal to 510. Well, 510, you can't do 510. You're going to have to either change that into a workable. So that'd be 510 divided by 1,000. So that would be 0.51 or more. And they're trying to trick y'all. So draw a picture. Mean is equal to 0.48. And the standard deviation is 0.02. So that's going to be 0.50, 0.52, 0.46, 0.44, 0.42. So 0.51 is going to be right in here. And they want to know that area right there. And this is 9999. And anyway, so punch in your calculator. I'll let you look at the picture. There we go. So second bars, normal CDF, and that's going to be from 0.51 to 9999. You got a standard deviation of 0.48. I'm sorry, a mean of 0.48 and a standard deviation of 0.02. .0668. So that area is 0.06. I do not like the way they word in these questions because they're trying to trick you. 0.0668. See? Now they're wanting you to do 510. Let's see what they get. .0288. Okay, I'm going to have to. I see why you sent these questions, Miss Yates, because they're tricking you with this 510. And on the previous problem, they didn't change anything, and on this one they did. And I think it's the wording. These questions are worded a little bit different. I've never seen these questions before. So these, from the last question, these are worded differently. Let me see what they're going to do. I know time's up and some of y'all are going to go into convulsions, but I just want to see. Okay, they got a standard deviation. That's what I did. That's what I did. I did that. I got a new P hat. Ours was 0.51. I swear, I think I did the same thing. Okay, what I'll do is I'll go over these over the weekend. I'll figure them out, and we'll just plan to do. I'll just plan to do homework questions, and if we do have some time to go through 9.2, we'll continue to work on 8.1, 8.2, and 9.1. I'll figure these questions out, and we'll go over these questions. We'll keep them on the email, and I'll go over them Monday. Okay. Okay, Hubert, that's fine. Thank you. Appreciate it. Y'all have a good weekend, and I'll see y'all Monday, okay?
Have a good weekend.
All right, thank you.